Hello and welcome to another introductory statistics instructional video. Today we'll be talking about the one proportion z-test and how to use this in StatCrunch. For this example, I will be using a sample of 1,000 randomly selected video games from 1988 to 2016 once again. Is it clear that I'm a gamer yet? Anyway, like the hypothesis test for one mean, a hypothesis test for proportions is taking a hypothesized value and testing to see whether the actual population proportion might be greater, less than, or not equal to that hypothesized value. Like with the one mean t-test, this is a yes or no question. So while the proportion, we may have evidence to believe it differs from our hypothesized value, we don't know how much it differs, like we would with a confidence interval. So these procedures are generally used hand in hand. We have the same step-by-step procedure for how we did the hypothesis test for one mean. So for this example, let's say that we're talking about the genre of these video games, and my friend says that 13% of video games are shooters. So games like Call of Duty or Borderlands. And I've seen a lot of Call of Duty games released over time, so I think, well, that's just preposterous. It has to be more than that. So the first step in order to answer this question is to define my parameter. Since we're talking about proportions, and again, this might be terribly written because I'm having to reach over my computer, we always use the letter P to denote a population proportion. And that's going to be the population proportion of games in the... I told you this is absolutely terrible. I'm very sorry. Shooter genre. Working from home is not easy, everyone. So we define our parameter. Again, that word population is very important because when we conduct inference on population parameters, not sample statistics. Once we have our parameter defined, we need to state our hypotheses. Again, we're going to have a null and alternative hypothesis. The null hypothesis is our initial information. It's our best guess what to believe. And the alternative is what we think is actually the truth, or what we want to test. We would always write our null hypothesis as H naught, or H with this little 0 subscript. Our parameter P equals 0.13, or 13%. While our alternative hypothesis, I believe that P is actually greater than 0.13. Again, we have to use that letter P to denote the population proportion. I don't want to see hypotheses with P hat. And I definitely don't want to see hypotheses with mu. We're dealing with proportions here, not means. So we need to have that parameter P. Sorry, my webcam is a little bit difficult to work with. Our next step is to check the assumptions. In order to meet these assumptions, we need to have a random sample. The games have to be independent of one another. And we have to have at least 15 successes and failures in our sample. Well, we're told this is a random sample of 1,000 games, so we're good on that front. I find it reasonable to believe that the genre of one game is not going to affect the genre of another game. To check successes and failures, I could construct a frequency table of the genre. And we see that we have 124 shooting games in this sample. That means that the remaining 876 are not shooters. That's definitely greater than 15 successes and failures, so we're good. We can run through this test. Next up, we need to state the significance level, and I didn't cover this until later in the means video, but it is very important that we define the significance level before we begin the test. The reason for this is because if we got a p-value of, say, 0.06 when running through this test, and we said, well, it's greater than 0.05, but it's less than 0.1, so I'm just going to say my significance level is 0.1. That's cheating. It's very unethical. Your whole research can get thrown out. Nobody likes it when you do that. So we need to define our significance level before we even run through the test. So I'm going to be basic once again and use a significance level of 0.05. Now we run the test in StatCrunch. For all of our proportion-related needs, we go to Proportion Stats, one sample. Now, if you have the number of successes and the total sample size, you could just use with summary, which we could do with this information from the frequency table. But I'm also going to show you how to use with data. We select our variable of interest. Now here where it says success, you have to define what your success is exactly as it is written in your data set. We have shooter here with a capital S, so we have to type it in exactly as it was. Once we got down to here, when we were running confidence intervals, we clicked this button here to change it. Here, we just leave it as is for the hypothesis test. We select our null hypothesis proportion in this first space. We can't change it from equals here. That's because we should always have an equal sign in our null hypothesis. And I believe that it's greater than 0.13. Notice that equal to is not an option for the alternative. It's either greater than, less than, or not equal. You should never have an equal sign in your alternative hypothesis. So I'm going to hit compute, and it's going to give me it's going to restate my hypotheses, give me the number of successes, the total sample size, the sample proportion of successes. That's standard error that was used for calculating the confidence interval margin of error, my z-test statistic, and my p-value. How to interpret these results is we look at this p-value here and we compare it to our significance level. If it's less than 0.05, then we would reject the null hypothesis and accept the null, since that is the significance level we decided before running the test. But since it's greater than, and this is very important, we fail to reject the null hypothesis. I'll go ahead and make the note right here. We have a fill-in-the-blank interpretation for these tests, just like with confidence intervals. But never, ever, ever say that you accept the null hypothesis. The reason for this is because the null hypothesis is just that, a hypothesis. We don't necessarily know whether it is correct or incorrect. It's just the best information we have to go off of. So we never accept it. We either reject or fail to reject it. Which brings us to this interpretation here. Now, if your p-value is less than the significance level, you follow the red text. If it's greater than the significance level, you follow the blue text. Because our p-value of 0.7137 is greater than our significance level, we fail to reject the null hypothesis. There is not sufficient evidence to conclude that the population proportion of games in the shooter genre is greater than 13%. Remember, we have to have that real-world context for the problem. One last interesting trick that you might see in harder problems is this z-test statistic here. This is actually just a z-score from a standard normal distribution. If we go back to the normal calculator, leave the mean at 0, the standard deviation at 1, so that it's a standard normal. If we plug in this test statistic here on the left side, and then we use the same sign in the probability statement as we did in the hypothesis test, we get the same value as our p-value. That's because this p-value is just a probability. It's the probability of getting a test statistic as extreme or more extreme than the one calculated using your data. Alrighty, now you know how to run through a one proportion hypothesis test. See you next video.